Hello everyone. Today I want to walk you through making your own lathe tools using Carbide and CBN as cutter materials. It's a long video, and for that reason I'm going to give you timestamps so you can watch parts of the video you're interested in. A lot of the clips are going to be sped up in order to not waste your time, but important sections will be in real time. The subjects are going to be application discussion, making the tool body, silver soldering the tip to body, silver soldering CBN, rough grinding Carbide and CBN, fine grinding and lapping Carbide and CBN, and finally testing in the lathe. To grab your attention real quick, I'm going to show you the CBN tool cutting an old thread gauge. It has rusted, so not to be trusted anymore, and the size is M105 by 2 mm, which I will never need, so no harm done here. It makes for a good test because these are very hard at 60 Rockwell C and made from tool steel. The tool left a beautiful finish. The inconsistencies in the rainbow pattern are probably smaller rotational errors in my spindle bearings or inconsistencies in the cross slide. Or maybe the tip radius is too small. Who knows? This cut was taken at about 200 meters per minute, which is around 600 feet per minute, and there is no visible wear mark on the tool after this small test. A project like this is a bit heavy on the required equipment, but nothing that a hobby machinist can't realistically attain over some years of the old iron fever, which is like gold fever but for machines and tools. So why would you make tools like this when there are an endless amount of different inserts to choose from? There are some good reasons. What you can make in your shop will probably be in your hands sooner than what you can order. You have full control over the geometry and sharpness of the tool. Also freedom in form factor, whether it's a specific grooving tool, a trepanning tool, a form tool, or a boring bar to fit a certain bore. You can make anything that may or may not be otherwise available. You can typically resharpen shop-made tools a lot more than insert tools. And of course, it's a skill-building exercise. Now, I will be the first to admit that insert tools are super convenient and I have a great selection of them. They are easy to swap out, and if you buy good ones, they give you unbelievable performance. But there is definitely a place in my shop for purpose-made tools that do not use an insert. For example, making tools with a very small corner radius and a positive rake angle to reduce cutting forces on finish passes, or just the opposite, custom negative rake or even tools with a K-land. There are so many things to try and test. In this case, I'm going to make two tools, one with a carbide tip and one with a CBN tip. CBN can be used to cut hardened steel because it's significantly harder than carbide and has high temperature resistance and chemical stability. To start, I'm sawing some steel blanks on my small bandsaw. I'm using the coarsest blade I can find because this is alloyed steel which has higher strength than mild steel. I got a pile of offcuts from a mold shop, so for all I know this could be some very fancy alloy of tool steel. We will never know. The push stick serves two purposes. It keeps my fingers away from the saw blade and also helps me apply pressure using my body weight. That's much easier on the hands for long cuts. Sawing can leave huge burrs on the part, so I'm taking some time to break the edges with a coarse file. You can do this with a grinder too or a belt sander. Notice how the table isn't moving around as I file the piece. Ever since I bolted this table down to the floor, it's been such a pleasure filing and hand sawing with this vise. Without a doubt, one of the best improvements you can do to a work table. To square up the block, I'm clamping it in the vise with a soft wire between it and the moving jaw. This way I'm sure to reference the fixed jaw as best as possible with the back face of the part. It also provides better grip on an uneven surface. For the first cut it isn't strictly necessary, for the second cut as well as the third cut it's definitely necessary. For the fourth cut all long faces except the top one have been milled square and parallel, so the part can be securely clamped square with just the hard vise jaws. This all assumes rotating the part towards the fixed jaw when flipping to the next face. Between every cut I file down every edge that I just milled to avoid burrs that may distort how the part sits on the parallels. To mill I'm using an 8mm carbide end mill in an AliExpress hydraulic chuck. I like this option because it doesn't throw chips all across the shop like a face mill would, and there is not much material to be moved, so it doesn't take very long. The hydraulic chuck clamps good, runs true, and it's very easy to switch tools, even with different diameters, by using straight collets. To square off the ends, I'm taking the easy way out by hanging the end of the part out of the vise and side milling it with the same end mill. I take good care in making sure my spindle is trammed in precisely, which will yield good squareness by side milling. That is, if you take a spring pass or finishing pass, because there can be a lot of tool deflection by doing this. I am taking out my regular vise and installing the swivel and tilt vise. I find this very handy to mill all kinds of angles on tool bits without having to tilt the head of the mill, losing my tram setting. Together with some angle blocks, I'll be setting the compound angles I have designed in these tools. These angles are designed for good clearance to get into tight spots when turning parts on the lathe. We all know how annoying it is when the live center gets in the way of a tool where you need to cut. Because of the high stick out of the part, I'm taking light cuts. I don't want to lever the part sideways and crash my end mill. This vise doesn't have a lot of clamping force, so while the part itself is stiff enough to take a heavy cut, the vise would let the part slip and cause a problem. Because of all the angles on this part, I can't use an edge finder to locate my features from. I'm using a precision ground pointer made from an old end mill as a visual guide to set my references. I am cutting the round slot for the broken end mill by plunging. It will produce a hole which is slightly larger than the end mill itself, which will give some room for the silver solder to flow between the carbide and the tool body. Test fitting the broken carbide end mill in the slot. It's not the exact fit or alignment that I wanted, but it will do the job. On a side note, when plunging in a partial hole with an end mill, it will push off out of the material towards the end of the cut. This can be largely alleviated by relieving the side cutting edge and shank of the end mill you are plunging with. With plunging, ideally only a small length of diameter should be in contact with the board that is being cut. In this case, I didn't take the time to prepare a tool for this operation. Anyways, it's good enough. Moving on. test fitting the CBN insert in its pocket. This is a small solid CBN insert and can be had on AliExpress for about €8. I'm center punching some raised points into the seat of the insert to give room for the silver solder to flow in between the CBN and the steel body. It's a very cool trick I learned from Blondie Hacks. The CBN needs to be prepared on the diamond disc. Roughing up the surface gives a better bond, just like glue joints. To hold the insert in place, I have bent a piece of TIG rod and shaped and clamped it into the vise. I must say that was one of my better ideas as of late. It's infinitely adjustable with some pliers and holds the piece in place perfectly with light tension. For silver soldering, I'm using some 55% silver solder and some white potassium salt-based flux. This kind of flux is very common here and has worked well in previous silver solder jobs I've done with steel, bronze, stainless steel and carbide. After the joint cooled down, I noticed that the solder did not seem to wet out on the CBN itself, and I decided to add more in the hope that it would make a good looking joint. And there I bumped the insert accidentally with the torch, and it just fell out. I was very confused as to why I was able to just knock the insert out so easily. I'm re-prepping the surfaces for a second attempt at silver soldering and watching out to try to not concentrate my heat too much and potentially cook the flux. There is a big blob of silver, and it was definitely hot enough to flow, but off camera the tip fell off again. Third time prepped and ready for another attempt, taking even more care to not overheat the flux and evenly heat the parts, but it wouldn't matter. The piece is easily broken off with some pliers. It's as if it's only held by the remains of the flux. I'm done for now with the CBN, so let's solder the carbide. I've done that before, so I know it works, and it will hopefully restore my sanity. First time good, and it withstands the beating of a wire wheel on an angle grinder. I'm starting to think there is some fundamental problem with silver soldering CBN in the conditions that I'm trying to do it in. One last attempt to silver solder the CBN with white flux. This time I'm using a wide heating torch tip to spread the heat better. And yet again the tip is easily broken off with some pliers. After posting about my issues on Instagram, I was pointed to some high-performance silver soldering products I'm able to buy in Europe. I bought silver solder specifically for soldering carbides and brown flux, which has properties close to the famous Harris Safety Silv black flux, which contains boron salts and has higher temperature resistance than the white flux. At this point, I realized I was fundamentally trying the same thing over and over again and expecting different results. I did some research and read some technical articles about brazing CBN. It turns out that it is possible under the condition that the CBN is metallized first in a sintering process, and the brazing takes place in a vacuum furnace. That seemed above my shop capabilities, so I went looking for another solution. And so I came across a useful insert shape. It's a 1/2 inch round insert with a CBN top layer and a carbide substrate, pre-sintered on the bottom, which I can silver solder to. These inserts are more expensive, 37 euros I paid for this, also on AliExpress. But it's large enough to be cut into 4 quarters and have 4 usable pieces to solder onto different tools. By the way, when grinding things, you should wear a respirator like this to protect your lungs. Grinding dust contains very fine, sharp particles which cause physical damage in your lungs and incite allergic reactions in some people to some of the metals that are in the materials we are grinding. I made a fixture for the D-bit grinder so that I can split the inserts into 4 pieces with a diamond cut-off blade. I noticed I wasn't making progress anymore and decided to take the wheel off and inspect it. To my surprise, what I thought was a thick layer of resin and diamond was actually a thin layer over a steel carrier. Lesson learned, don't buy the cheap diamond discs. I swapped the disc with a known high quality one and continued my cut. Due to the different insert size, I also have to recut the pocket in the body. At the same time, I will also add the positive rake angle at this stage. Since there is only a thin layer of CBN on top, I don't want to grind most of it away to make a positive rake tool. Silver soldering this new type of insert worked wonderfully in the first go and wetted out nicely everywhere I expected. Rough grinding the CBN insert with the diamond wheel on the bench grinder. I originally bought this wheel to sharpen my tungsten electrodes for TIG welding, but it works nice and quick for this too. Rough grinding of the carbide tool, first with the diamond cutoff wheel and roughing the facets with the diamond cup wheel. To finish the CBN tool, I'm starting with a 1200 grit diamond wheel on the slow speed diamond lapping machine with some WD-40 as cutting fluid. It keeps the wheel from clogging with dust. This CBN is pretty tough stuff, so I'm changing out to a 600 grit wheel to cut faster. The facets are shaping up nicely, but there is still a flat spot on the tip, so I have some more grinding to do. After I'm satisfied with shaping the insert, I'm changing to the ceramic lapping wheel to use with diamond paste to polish the insert. The diamond paste can be applied to the rotating wheel by hand, but it's necessary to dilute it with a solvent like WD-40 to spread the diamond particles evenly over the plate. The black streaks that are forming on the wheel is material that is being cut. It's a good indicator of where exactly you are cutting on the tool. This being a ceramic lapping plate, I can push the tool into it pretty hard without risking to damage the plate. It will polish the surface and leave a very sharp and crisp edge. I tried forming the radius using the lapping plate, but I was getting nowhere fast, so I switched back to the plated diamond disc to form the radius. For finishing the tool, I'm using 2 micron diamond paste. If I really wanted to, I could go finer, but 2 micron already leaves a very good finish. Maybe in the future I will make some tool that needs a higher finish, but for now this will do. Shaping the carbide tool is mostly the same as the CBN tool, but it goes much faster because it's much softer than CBN. To start, I'm grinding a very small positive rake angle on the tip of the tool. I tried the ceramic lapping plate straight off the D-bit grinder finish, but found the angles were too different, so I had to go back to the diamond disc first to do some more forming, and then use the ceramic lapping plate to finish the surfaces. The carbide shapes and polishes very quickly with the slow speed diamond grinder. It's an absolute joy to use. If you have the need to grind and polish carbide and ceramics, I cannot recommend building one of these enough. To test the carbide tool, I have some 316 stainless steel. The purpose of this tool is to be able to take a very small cut and still leave a good finish. The first cut is 0.2 millimeters, the second cut is 0.05 millimeters, and the third is 0.02 millimeters, about 1/1000th of an inch. The CBN tool gets a harder test. This is a 60 HRC 2mm deep case hardened shaft that had some previous tools struggle on it. The dull spots in the finish is where the case depth has been reached and the material is no longer very hard. So there it is, shop brazed CBN tool for hardened steel in any size or shape you would want built in your own shop. These specific tools I made now are what I would consider general purpose finishing tools, and I expect to be able to use them in some upcoming projects. However, I have some other projects upcoming that will require purpose-made tools to do the job. Without the capacity to make the tools, I would have to compromise in the design of the project or in the quality of the result. I hope this video was useful if you're also looking to make your own tools like this. If you have any questions, feel free to ask and I will answer to the best of my ability.